Dear viewers, welcome again in Chemistry with Fun. Today I am going to discuss radioactivity lesson 3. In lesson 2, I have discussed the cause of instability of a radioactive nucleus, and the cause is the neutron to proton ratio. The radioactive nucleus becomes stable by emission of alpha particle, beta particle, etc. Today I am going to discuss the properties of alpha, beta and gamma particle. Okay. Let's start with alpha particle. We know that alpha particle consists of 2 proton and 2 neutron. So, as it consists of 2 proton, 2 neutron, and proton has proton has 1 positive charge, so alpha particle has 2 positive charge and neutron is chargeless, so it is denoted by 2He4 because proton's mass, one proton mass is 1 and neutron mass is 1, so 2 proton plus 2 neutron, mass number become 4 and it is denoted by a helium atom. As the alpha particle is mass number high, mass of alpha particle is high and it is large in size, so its velocity is less than other particle. Okay. Now its kinetic energy. It is denoted by half mv square. The mass is high, velocity is low, but due to the high mass, the kinetic energy of alpha particle is also high. Momentum, which is denoted by mv. Momentum is the multiple of mass and velocity. Mass is high, so momentum is also high. As alpha particle carries two unit positive charge So its charge will be double of a single proton, because alpha particle carries 2 unit positive charge, and then its charge will be double of a single proton, and the charge become 9.6 into 10 to the power minus 10 electrostatic unit. It is ESU, electrostatic unit. Okay. The mass of alpha particle is 6.642 into 10 to the power minus 24 gram, and velocity is 20,000 to 30,000 kilometer per second, which is 1/10 time of the velocity of light. Now comes to its penetrating power. Penetrating power. Due to large size of alpha particle and lower velocity, the penetrating power of alpha particle is low. Due to large size and low velocity, the penetrating power of alpha particle is low. As the penetrating power is low, so it is less harmful for human cell. Okay. Now comes its ionizing power. Due to high charge of alpha particle, it has high ionizing power. can easily ionize gaseous medium. Ionizing power means distribution of charge to a chargeless medium. Okay. What occurs when a alpha particle is emits from a radioactive nucleus? We know that alpha particle is denoted by 2He4. It is alpha particle. Okay. Let's take an example. X is a radioactive nucleus. Z its atomic number and A its mass number. Okay. A mass number, Z atomic number, and X is radioactive nucleus. Okay. When an alpha particle ejects from a parent radioactive nucleus, then the atomic number is decreased by 2 and mass number is decreased by 4 in the daughter nucleus. Okay, means when an alpha particle ejects from a radioactive nucleus means parent radioactive nucleus means a radioactive nucleus. Then after ejection of an alpha particle, the new nucleus which is formed, it is decreased atomic number by 2 and mass number is also decreased by 4. Okay, let's take an example. If X is the parent radioactive nucleus, its Z is the atomic number and A is the mass number. When an alpha particle emits from it, alpha means naturally is a helium atom. Okay, then the daughter radioactive nucleus is from let Y, then its atomic number is decreased by 2 from parent and mass number is decreased by 4. Okay. Let's take an example. Uranium 92, its mass number is 235. When an alpha particle ejects from it, it's become thorium, atomic number become 90 and mass number become 231. Okay. But this product directly not formed. In middle stage, a transition state is formed, which is that let X, atomic number Z, mass number A. When an alpha particle is ejects from it, it's as it is neutral molecule, neutral atom, and alpha particle means 2 unit positive charge is ejects from the nucleus. As 2 units positive charge is eject, then it's form an anion which has 2 unit negative charge. This anion, this 2 unit negative charge is released in the surrounding and this nucleus become neutral and the released amount of negative charge is captured by the alpha particle. Then it's become a minus 4. As a result, we get in nuclear reaction not charged product, only chargeless product. Okay. Let's come to beta particle. Beta particle is have same charge of an electron, that is 4.8 into 10 to the power minus 10 ESU, means electrostatic unit. Mass is very low, (9.108 10 to the power minus 28 gram, and it is very teeny particle. small particle. Beta particle is denoted by it is similar charge of electron, so it is denoted by or is as the mass is very low, so its kinetic energy will be low. Due to low mass. Its momentum due to low mass, its momentum, which is multiple of mass and velocity, is also low. Oh, I have not discussed about velocity. Velocity of beta particle is very high, near about 2.3 into 10 to the power 8 meter per second. As its mass is low and velocity is high, its penetrating power is also high than alpha. Mass is near about 1 by 1836 times of a mass of proton. Okay, penetrating power, ionizing power. Let's come its ionizing power. Due to low kinetic energy, its ionizing power is also low. This is the basic characteristics of beta particle. But what occurs when a beta particle is ejects from a radioactive nucleus? Let's see. when a beta particle ejects from a radioactive nucleus from a parent radioactive nucleus. The mass number is not changed in the daughter nucleus, but atomic number is increased by 1 unit. Okay? But when a beta particle ejects from a radioactive nucleus, the mass number in the daughter nucleus does not change, remains same, but the atomic number is increased by 1 unit in the daughter nucleus. Let's take an example. We studied that in discussion of instability of the radioactive nucleus, a beta particle is ejects from a nucleus when neutron to proton ratio become too high. Then beta particle ejects from a radioactive nucleus. On the phenomenon of rejection of beta particle, a neutron is converted to a proton by emission of electron or beta particle. So let's neutron, chargeless, mass 1. When a beta particle is emits, it's converted to a proton, become zero, and together it some energy is released, and an anti-neutrino particle. This is neutrino, and bar of V, this is anti-neutrino. Anti-neutrino particle also released. This anti-neutrino particle is chargeless and massless. Means it has no charge and no mass. Okay? Let's take an example with a radioactive nucleus. Let's X is a radioactive nucleus, Z is atomic number, A is mass number, it is parent radioactive nucleus. A beta particle is ejects from it, beta, or this is denoted by beta particle. Then when a beta particle ejects, means an electron emits from the nucleus, means it's formed a cation in transition state, means the daughter nucleus become Y, its Z plus 1, mass number does not change, and form a cation. This cation is balanced by an electron. Then product form. This is the parent radioactive nucleus. And it is daughter. And when the beta particle is released, some energy also released. And in radioactive reaction, we know that the energy on the left hand side and right hand side remains same. But in examination, we see that the reactant energy is higher than the product. Then the energy is conserved by the chargeless particle antineutrino. This is chargeless and massless. Okay? This means the antineutrino particle which is released along with beta particle in the nuclear reaction, which is chargeless and massless, conserve the charge energy in the nuclear reaction to maintain the nuclear reaction in balanced condition. Okay? Now we come to gamma ray. Gamma ray. Gamma ray is an electromagnetic wave. Electromagnetic wave. It is massless. Due to electromagnetic wave, electromagnetic in nature, it is also chargeless. As it is massless, so its kinetic energy is zero, because kinetic energy is denoted by kinetic energy is zero, and because kinetic is denoted by half mv square. Due to massless, mass is zero, kinetic energy becomes zero. Momentum is also zero. Because momentum is denoted by mv, mass m is 0, so momentum is 0. But its velocity is, as its electromagnetic wave, its velocity is same to velocity of light. Light, that is And due to high velocity, its penetrating power is also high. And as it is chargeless, so it cannot ionize any medium. Okay, this cannot ionize any medium. And due to high its penetrating power, it is harmful to living cell. And gamma ray is denoted by this because it is chargeless and massless. Okay. Then when a gamma ray emits from any radioactive nucleus, like suppose C614, gamma ray emits, there is no change. It remains same because gamma ray emits on that time when the radioactive nucleus already ejects alpha and beta, because the exit amount of energy is released in form of gamma ray or X-ray. Okay. Now this whole discussion can conclude in a single chart. We can compare alpha, beta and gamma ray in a single chart. Let's see. Mass, mass of alpha is highest among them, then beta, then gamma. Velocity, the velocity of gamma is highest among these three because the velocity of gamma is same to light. Gamma, then beta, then alpha. Kinetic energy, alpha, beta, gamma. Momentum, alpha, beta, gamma. Alpha is highest among three, in middle beta, then gamma. Penetrating power, due to highest velocity of gamma, then penetrating power is gamma also highest, then beta, then alpha, because penetrating power depends on velocity. Ionizing power, due to highest charge and heaviest mass of alpha, alpha has highest ionizing power, then beta, then gamma. It is alpha, it is beta, this is gamma. Okay, we know that both beta and electron is negatively charged particle, but what is the difference between a beta particle and an electron? Let's see. In case of electron, what occurs for electron? Electron rotates at its own axis around the nucleus. But for beta particle, what's occur? Beta particle source is nucleus, but it does not present in nucleus. Present in radioactive nucleus. When the neutron to proton ratio become high in a radioactive nucleus, then to minimize the neutron proton ratio, a neutron is converted to a proton, and a neutron is converted to a proton and ejects a beta particle in form of electron. This is beta particle. In case of electron, when an electron removed from its outer orbital, there is no change occurs inside the nucleus. Because electron is moving around its own axis surrounding the nucleus, around the nucleus, and the nucleus forms a ion, that is cation. Let's take an example, sodium. When an electron emits from it, then it's from sodium cation. But when a beta particle is removed, from a radioactive nucleus, the electronic configuration does not change because beta particle emits from the nucleus. Then atomic number is increased by 1 unit in daughter nucleus. Let's take an example. It's (1940). When a beta particle is emits, then it's become 20, daughter nucleus 40. Atomic number is increased by 1 unit. X here is parent, Y daughter. Okay. These are the comparison among the rays emits from different types of radioactive nucleus. Okay.